have the pleasure to introduce the next speaker, who somehow suspiciously looks a lot like me, is dressed like me.
He's a very handsome guy, isn't he? I'm sure you'd agree.
Here comes the Ben in Black.
Oh, no.
Ben is not me. He is very highly experienced senior data expert, also with backgrounds in telecommunications, in the financial industry. We just, over the dinner last night, we spoke about using graphs to tackle financial fraud and how that was the worst job ever, right?
It was pretty hard going.
Incredible amount of experience and charm. So I'm super excited to have you with us. Please take the stage, and for you in the audience, small applause at the beginning for Ben.
Thank you very much. Cheers. It's a real honor to be here today. And I would like to just talk to you about some interesting ways of thinking. And in fact, actually, the question about MCP, I think, was very timely and works beautifully because Charlie and I work very closely together. What I want to do is sort of leave you from a talking perspective around effectively 4 different points. One is the idea that if we're going to understand how AI works and talk about artificial intelligence, we need to understand how we think and actually the flaws in the way that we think and how those flaws are actually designed in. Secondly, I want to talk a little bit about what AI is and what it isn't, and sort of give you some ideas, maybe you'll be familiar with, but that you can use, if you are familiar, to be able to explain to people its limitations and how we can think more completely about it. Then I'm going to talk about how agentic AI and MCP, I think, is the most promising thing that's going to happen. But it has to be tempered, which is the 4th point, with the DKG and with neuro-symbolic AI for us to really unlock the power of agentic AI. So, spoiler alert, I've just told you all of it in the first minute. So yes, I've had a lot of unusual roles. I chair the AI forum at the EDM Association. I teach the 2 flagship courses, and I worked in a bunch of really fascinating financial services and telecommunications companies. I'm primarily an advisory consultant, as I've been advised to describe it over lunch, and I help large multinationals, thrive with their data management, analytics, and AI as part of Ortecha, which I'm very proud to work for as a partner. So first of all, I'm going to give you some really wacky ideas here, and I hope that they sort of inspire some thinking, because I do like to think around problems. So our capacity to recognize the truth is going to be really important. Critical thinking, we've talked a lot about fake news and how AI can be manipulated against us. We need to really be thinking about how can we be deceived. And I've been very inspired by Chris Reining's talks over the years. He's a truly inspirational and brilliant man. And when I was thinking about how I could put a different view on this and sort of also try and tell the same cautionary tales, I was thinking about Donald Hoffman's book, The Case Against Reality, which is a really powerful book. It's not about AI at all. It's actually about the mental constructs that we use and the fact that we don't actually experience what's real. We experience what's convenient for us to evolve. We don't see muons passing through our bodies and through the earth. That would be completely pointless. We don't see the full spectrum of colors that other animals and birds. We don't see infrared, for example, like snakes and cold-blooded animals that need that heat to survive. That would be calorifically silly, because evolution requires us to be efficient. So if I don't exercise, my muscles atrophy because my body's not going to spend that energy on maintaining those muscles. So we need to be thinking efficiently, and actually machine learning is wildly inefficient in its use of energy, as I'm sure you'd appreciate, and symbolic AI is wildly efficient. So there's some interesting angles there, but the important thing is we deliberately make mental models. We know that most of this, physics would tell us, is space, but I experience it as solid because of the forces pushing against me. We construct a convenient way of traversing through life. Now, sometimes those models work terribly against us. And I could talk to you about seeing clouds as shapes, you know, like faces and horses and things, and how moths can are attracted to flames, thinking it's the moon, and then ultimately die. But I'm going to give you a much more silly example of the male Australian jewel beetle, which tragically thinks that small brown stubby beer bottles in Australia primarily are incredibly attractive female beetles, and spend a huge amount of time attracted to these beetles to the extent that they die, tragically, from heat exhaustion. So this is where their mental model of reality is actually working against them. They are experiencing something that is synthetic, that's artificial, as if it's real in a different or a natural. And so we really need to be thinking about that when we think about AI, because actually we do project and humanize things. So I'm going to give, back in the 1960s, a gentleman called Donald Mitchie came up with a means of describing a physical neural network. And what he did was he took the game tic-tac-toe, or as we call it in the UK, what do we call it? Noughts and crosses. Noughts and crosses. And he decided that he was going to create an algorithm around this, a physical algorithm of matchboxes. And each matchbox represented a potential move in that game. And then he used beads or colored marbles, small balls, to be able to indicate which move should be made next. And he threw those in, effectively, and then started playing games against it. And he was doing this very rapidly. He did 200 games with it, and at the point that, and each time it made a good move, he would change the way the marbles were configured. And every time it did a bad move, he would do something slightly differently, until he was effectively training a physical neural network of nodes to learn good and bad moves in noughts and crosses. And after 200 games, it was almost unbeatable. It would force a draw, or it would win against human beings. That's human beings losing a game to a bunch of beads or marbles in matchboxes. A beautiful way of illustrating, in my mind, or my view, what we should be thinking of with regards to neural networks. Because of course, this is a grossly simplified view of neural networks. But I was using these things back in 1998 in backpropagation neural networks at Bristol University. And I was really fascinated by the different layers. You can think of all of these effectively as little matchboxes with little beads in them that have been trained by vast amounts of text from the internet. Now, I'm sure we're all familiar with that. But that training set is dysfunctional. If you've ever been on a Reddit forum and seen people argue crazy things, this is, we've encoded our thinking as vocabulary that is now being trained and then determining how reality works based on the thinking that created the words that created the internet. So if we see it lying or being self-preserving or doing all of these things, I think there's a fair probability it's just mirroring human nature from the text that it's been trained upon. So if we want it to be better ethically, we need to give it better ethical data, of course. Okay, so new paradigm that I would like to take you through. First of all, we've been interacting with technology for most of our lives in a deterministic manner. You put a question into SQL of a database, it will always give you the same answer unless something significant is changed around the database itself. And so consequently, that's a deterministic response. We talked about probabilistic responses, in which you can ask the same question repeatedly, and you will get a different answer every time. And that is a weird paradigm for us to get our heads around, having worked with technology for more than 60 years now. SQL has been around, which has always been the main paradigm around that. So when we think about trying to get our heads around that, that's very much more like the way that we would interact with a human being. If you were to ask me the same question now, and then maybe 2 years later, I would hope that I would give you a slightly more nuanced or learned answer, because I'm here to learn. And I love the point that Bob made about listening, because I'm here to listen and to learn and read books and pass on the things that I learn as well, so that we become better than the sum of our parts. That's actually not inconsistent, that's evolving. But when we think about AGI and the idea of an all-powerful AI, I think this is a really interestingly bizarre question to be asking. Because we want to interact with AI like it's a human, right? A human that knows everything, is never wrong, and can do anything. So not very human at all. In fact, I mean, our mental models are not well figured to be omnipotent, omniscient, and all of this good stuff. So actually, if you had an employee in your company like that, they would be wildly expensive, probably very calorifically intensive as well. They would be a massive key person risk. If they got compromised or decided they didn't like your company anymore, you're in trouble. Do we do that? Well, actually, no. We get teams of experts. We actually compartmentalize concerns. That's actually how we would manage risk in most of the banks that I used to work. We didn't make checkers. In fact, there's regulation associated with this. So Agentic AI, a team of smaller experts, often with small language models rather than large, can get you better results, more calorifically, powerfully, yet it is seriously limited. And I'm a big fan of MCP too. But the important thing is we should not be thinking like these beetles and seeing something that isn't there. We need to know its limitations. And that's what I love about Chris Reining's talks, for example, which is optimism with being sort of tempered with the skepticism we need to be able to detect the flaws in our mental models and address those. So I'm aging myself somewhat, but if you've ever seen Zoolander, I always felt sorry for Mugatu, who was the bad guy, but he was the only one that recognized that Zoolander only really had one look. And that was, of course, the joke. Robotic process automation has been around for more than 40 years, and an awful lot of the thinking around MCP has completely disregarded this. There's a fabulous article by Julian Seaman that I've included a link in that really talks about this. So, when we think about sort of agentic AI, isn't it just a continuation of learnings that we should have baked in from the learnings of robotic process automation, or indeed our friend the paperclip way back? Again, I'm aging myself. I'm 50 next year, so I've lived through a bit of this. But joking aside, there are significant limitations associated with MCP, and if we're aware of those, we can work around them with things like the distributed knowledge graph. And those limitations, and I want to keep underlining, I think it's the future, agentic AI, but we have to manage it carefully to be able to do that. So things like one agent networked with many other agents and networked with many other different systems will be experiencing different data structures without a Rosetta Stone, to riff on Charlie's beautiful idea. So there's a real risk that the data structures are incompatible unless we provide something that makes them compatible. The other aspect is it assumes clean data, and there's been many talks and I specialize in helping people clean their data, of course, and structure it in the right way. But it doesn't know what clean data is unless you tell it. So if you haven't programmed it in terms of the data quality rules around what's fit for purpose, it doesn't know. So it's just going to assume it was right. There are some problems associated with session leakage and rigorous security for agents that you need to impose on the top of that. And of course, you can work around, but applying things like zero trust data entitlements and other aspects of least privilege will enable you, with things like the DKG, to be able to limit it to what the blast radius of what can go wrong, what it can corrupt, what it can access. And then session management you have to impose, because session leakage between one agent that can see something and another one that shouldn't but now can is a real problem unless you build that in. The other one, being able to see actually what it's doing on your behalf, and then in terms of cost attribution, you can't limit the tokens through NCP, so of course, and nor should you perhaps, but you do need to make sure that it doesn't overspend, and when it does run out of tokens, it fails gracefully. So if it was halfway through planning your trip to Ljubljana and then decided it ran out of tokens, you don't want half a trip having been booked. It's not useful. So, little bit of a joke here, but A team of interconnected agents replacing people is more likely in its current state, and that's interconnected agents, a network of them, rather than the single instances on a particular system, which are actually quite safe. Leads towards unchecked spending, weak security, and a network of idiots, potentially amplifying mistakes. And so a little bit of a joke about consultancies there. Large consultancies, I might add, not the advisory specialists that we have with us today. But yes, it's obviously encroaching into their business model, so we need to make sure that that's contained too. But look, I've actually covered many of these as I was talking about the limitations, but actually at almost every single turn, there are things about origin trail and the distributed knowledge graph, the ability to be able to use interoperable data sets that are well described rigorously and then contain those in such a way that enable the agents to be contained in what they can see. And then, of course, when we're talking about the new X402, if I remember correctly, the ability to be able to actually then determine the costs associated with things, these are all going to be greatly improved by combining neuro-symbolic AI, the distributed knowledge graph, and this incredibly powerful network of agents that will actually be amplifying the better aspects, not the worst aspects of each other. So we see these shapes in clouds, and let's hope we continue to do that, because we're creative beings. But we also need to recognize the limitation in the way that we think. So we need to make sure that we don't believe the hype, or maybe just a little bit, but we use the hype and the momentum to be able to ensure that we're thinking the right way around data, the right way around AI, and it works for us rather than against us. That multimodal AI, like neuro-symbolic AI, is the way forward. Agents are the future, but when you network them, you need to make sure that they're going to amplify the benefits. And then finally, you need the DKG. So that's the end of the talk, but I'd love to connect and continue this conversation. So thank you very much for giving me your time.